Welcome to chemistry class with your teacher and a quick Christopher GK. All right, this particular video will be looking at a very important topic. The topic is compounds of halogens. In the last video, we treated chlorine and other halogens, but here we are going to look at some compounds of halogen, and it's expected by the end of this class or this video, you should be able to learn, at least you should have able to list 5 examples of compounds of a halogen. It's expected by the end of this particular video, you should list at least 5 examples of a compound or compounds of a halogen. Number 2 is you should be able to explain the laboratory and industrial preparations of hydrogen chloride, and you should be able to state the laboratory preparation, chemical properties and physical properties, and also uses of chlorides. Finally, tests for chloride, you should also be able to learn that by the end of this video. So these are the things we want to look at in this particular video. So let's take them one after the other and we'll run it down. Now, we'll start by compounds of halogen. What actually halogen is and the compounds. Of course, in our periodic table, we know that group 7 elements are the halogens. We have fluorine, we have chlorine, we have bromine, we have iodine, and on it, we know that their reactivity varies, but they are very, very reactive elements in the periodic table. So, naturally occurring compounds of halogens are, we have halogens as one of the elements that are very, very reactive, and they do not occur free in states or in nature because of their reactive nature. Because that halogens are very, very reactive, they do not occur naturally, they do not occur free in nature, rather they occur in a combined state. For that reason, chlorine combines with most of the elements except carbon, oxygen, nitrogen, and noble gases. Astacene is very unsuitable, is reactive, and was sensitized in very minute amounts. It's been synthesized in a very minute amount in 1940 by chemists in US. So one thing we are trying to establish there is that because that halogens are very, very reactive, they do not occur freely in nature, rather they occur in combined states. Fluorine occur in a combined state, chlorine the same thing, and others, because they are very, very reactive. Okay, the non-naturally occurring compounds of halogens are calcium fluorides, sodium hexafluoroaluminates, sodium chlorides, and the sodium triiodate 5. These are the naturally occurring halogens, and in it, they occur in different parts of the world, like that of the calcium fluoride. We have it's been found in England, and the sodium chloride is found in sea, water, and in rock. And the sodium triiodate 5 is being found in Chile. So, but these are the naturally occurring halogens. Let's take them one after the other. Once again, calcium fluoride, which is CaF2, occurs as fluorspar in nature and is prepared by the action of calcium triosocarbonate 4 and dilute hydrogen fluoric acid. That means hydrogen fluoride, that of the acids. Now, the reaction is being represented below: action of calcium carbonate and the dilute hydrofluoric acid. And when calcium fluoride is heated, the calcium reacts with conc H2SO4 to liberate hydrogen fluoride gas, as shown in the diagram below. So, with that, we can see how calcium fluoride, which is CaF2, is being formed, is being prepared through calcium carbonate. And sodium hexafluoroaluminates occurs in nature as cryolides, while sodium chloride, which is normally called the common salt, occurs in nature as salt deposits, either in a sea salt or in a concentrated form. It can also be found in a rock. All right, it can be obtained through mining of salt deposits. We can also obtain sodium chloride by evaporation of shallow sea salt. By sun, we can get it also by passing hydrogen chloride gas into a saturated solution of impure salt. Then the pure sodium chloride is precipitated and crystallized out as colorless transparent cube. The pure sodium chloride is precipitated and crystallized out as colorless transparent cube. Sodium triiodate 5, how can we get it? Where are they being found? Of course, I talked about it before. I said it before that it's been found in Chile, and it's been isolated. So this is found in Chile, saltpeter, from which iodine can be isolated. You know, iodine, we got iodine in sodium triiodate 5. So through this particular combined state, iodine is being isolated, as the case of this particular equation below. You can see that iodine solution is being isolated there and is being gotten as an element here. So these are the naturally occurring halogens. We are going to take fluorine first of all and talk a little on that before we move to the compounds of halogen. Fluorine is the most reactive of halogens and the first member of the group. It's the first member of the halogen family, and the name is derived from a Latin name, flo, which means one flow, Fluorine is not found free in nature because it's this great reactivity. It is found in combination with other elements, either in fluorspar, or we call it fluorides, or cryolides, or fluorspatides. These are the area in which it can occur as a compound in a combined state. The way we have all in a combined state is being found in this way because it's very, very reactive. It cannot occur free in nature. Okay, now compounds of of halogens, one of them is hydrogen chloride. We are going to look at this intensively as one of the compounds of halogen and discuss the properties and other things that has to do with this. So hydrogen chloride exists as a gas at STPs. STP means standard temperature and pressure. And when it dissolves in water, it forms hydrochloric acid. So hydrogen chloride, when it dissolves in water, it forms hydrochloric acid. The same formula, but the pronunciation and their existence differs. Hydrogen chloride is a gas, but hydrochloric acid is an aqueous solution. All right, pure hydrogen chloride was found prepared in 1772 by Priestley, a scientist who called it marine acid gas because of what? It was made from sea salt. Hydrogen chlorides occur in traces in the air as an industrial byproduct. It is considered as an air pollutant, but can be readily be washed down by the rain because of its solubility in water. Of course, when it's dissolved in water, it becomes, when it's being added to water, it becomes hydrochloric acid. How can we prepare it in the lab? How do we normally prepare hydrochloric acid or hydrogen chloride, in the lab? The setup is what you are seeing on in your screen, laboratory preparation of hydrogen chloride. As you can see, sodium chloride is in a beaker, and the concentrated sulfuric acid, which is HCl4, is being poured into the beaker through, not the beaker, conical flask, I mean, through the test tube funnel. And you see the setup, the sulfuric acid to dry the gas, and the hydrogen chloride was now gotten through downward delivery. And the equation for the reaction is what we are seeing here. Sulfuric acid plus sodium chloride to give sodium hydrogen sulfate and hydrogen chloride. The equation for the reaction is below, and that is how it's been prepared in the lab. All right, let's talk about it in a detailed way. Hydrogen chloride is prepared by the action of a hot concentrated tetraoxosulfuric acid on sodium chloride. How do we do it? We put some sodium chloride in a round bottom flask. Then we add concentrated tetraoxosulfuric acid through a test tube funnel and heat the mixture. When it's being heated, a gas is dry. That particular gas that is being passed through a concentrated tetraoxosulfuric acid to dry the gas. And that particular gas will now, the dried one will now be collected by downward delivery, as we see it in the image here. Then it will be collected through downward delivery. And the equation for the reaction, of course, we have done it. This is it. And the hydrogen chloride gas will be collected. Okay, but industrially, in the industry, it's been prepared in a different way, because it's been prepared in a larger quantity, and they do it in a way that it will be easier for them, and they can produce it massively. So hydrogen chloride is prepared in large quantity by the direct combination of hydrogen and chlorine gases obtained from the electrolysis of brine. Of course, the electrolysis of brine, the two products we get from electrolysis of brine is hydrogen from cathode, chlorine gas from anode. Then when two of them is directly combined, it will form hydrogen chloride. So this is where how it's been prepared in the industry, from the industry, direct combination of hydrogen and chlorine. Okay, what are the physical properties of hydrogen chlorides? One of the physical properties is this: is a colorless gas with a sharp irritating smell. Number two is that it is about 1.25 times denser than air, meaning that it's heavier and denser than air. Number three is that it turns moist blue litmus paper red, showing that it's an acidic gas. Still remember that we said that when it dissolves in water, it turns to hydrochloric acid. So it has the acidic character. When it come in contact with a moist litmus paper. All right, it is very soluble in water, forming an aqueous solution of hydrochloric acid. It's very soluble in water, and it fumes strongly in moist air, forming droplets of hydrochloric acid. Number six is that hydrogen chloride does not burn. It does not burn, or what does it mean? It does not support combustion. Dry hydrogen gas, dry hydrogen chloride dissolves readily in non-polar solvents, something like chloroform and toluene, but it does not ionize as it does in polar solvents. So dry hydrogen chloride dissolves readily in non-polar solvents. That is one of the physical properties we have discussed. And we need to look at the chemical properties, chemical behavior of hydrogen chloride. Of course, when it dissolves in water, it is hydrochloric acid. The same formula, there's no difference between the formula of hydrogen chloride and the formula of hydrochloric acid. The same formula, but it's just the state, gaseous and the aqueous solution. Now, one of the chemical properties of hydrogen chloride is reaction with ammonia. Hydrogen chloride gas reacts with ammonia to form dense fume of solid ammonium chloride. When it reacts with ammonia, it forms ammonium chloride. hydrogen chloride also reacts with metals. And when he does that, the metal will displace hydrogen from that particular gas, and it will form a salt of that particular metal. Something like zinc. Zinc reacts with hydrogen chloride to form zinc chloride, a salt. Then iron also does that. Iron reacts with hydrogen chloride to form iron 2 chloride. Now we need to understand that hydrogen chloride is readily soluble in water, and that is why it's being used in fountain experiments. The fountain experiment is used for that. That is how it's being used, why it's being used for that. Now, we have talked about hydrogen chloride. Now, hydrochloric acid. Still know once again that hydrochloric acid is the same formula with hydrogen chloride gas, but only difference is that hydrochloric acid is a solution of hydrogen chloride gas and water. That is what we mean by hydrochloric acid. The solution of hydrogen chloride gas in water is known as hydrochloric acid. So how do we prepare it in the lab? The laboratory preparation of hydrochloric acid is this. It's being prepared by dissolving hydrogen gas in water. When it's been done that way, hydrochloric acid is formed. So the gas is passed through an inverted funnel. Hydrochloric acid ionizes in aqueous solution to give hydrogenium ion and a chloride ion. All right, let's take a look at how it's been prepared in the lab, the image of inverted funnel. Look at it. Now, hydrogen chloride gas is being allowed to pass, it will dissolve in water through an inverted funnel. Then the aqueous solution there is hydrochloric acid is now the acid. Okay, what are the physical properties of that? As an acid, of course, it dissolves in water to form hydrochloric acid, which exhibits all the usual properties of acid. With metals, of course, they are more electropositive. Metals with more electropositive than hydrogen will liberate hydrogen gas from the acid. Of course, it will displace the hydrogen from its place, and the metal will be there. With base, when it reacts with base, of course, hydrochloric acid reacts with base or an alkali to form salt and water, which is what we call neutralization reaction in chemistry. When an acid reacts with base to form salt and water. So hydrogen chloride does that. It reacts with acid base to form salt and water. Hydrochloric acid, that's what we mean. Then another physical properties of this we mean chemical behavior and physical behavior and chemical behavior. These ones we are talking, they are the chemical behavior of acid. Then C, another reaction or chemical property of hydrochloric acid is that the reaction with carbonates. Hydrochloric acid reacts with triazocarbonate 4, and the hydrogen triazocarbonate 4 is liberated. Okay, it reacts with hydrogen carbonates, it reacts with triazocarbonate, and it also reacts with hydrogen triazocarbonate to liberate carbon 4 oxide. Now, as we can see, when he reacts with sodium carbonate, sodium chloride will be formed, but when he reacts with hydrogen triazocarbonate 4, carbon 4 oxide will be liberated in such a case. Now, it can also react with triazo sulfate 4. And when he does that, it will liberate sulfur 4 oxide. If you react with triazo sulfate 4, it will liberate sulfur 4 oxide. As you can see, the reaction of potassium triazo sulfate 4 with hydrochloric acid, it will form potassium chloride and sulfur 4 oxide, then water will also be there. Now, hydrochloric acid also can react with iron 2 sulfide. It can also react with iron 2 sulfide, and when it reacts with iron 2 sulfide, it will liberate hydrogen sulfide gas. It will liberate hydrogen sulfide gas, and as is being represented in the equation below. These are the reaction we have discussed. Number one is as an acid, Look at it as an acid. He undergoes all these reactions, A, B, C, D, A. Then, as a precipitating agent, he can undergo, we have discussed when hydrochloric acid exhibits as an acid. Now, as a precipitating agent, hydrochloric acid is added to silver triazonitrate 5 or lead-2 triazonitrate 5 solution. When it's being added, a white PPT of silver chloride or lead-2 chloride is formed. We use this in the lab when we are testing for a particular, when we are testing, having our analysis. We use this in the lab. White PPT of silver chloride will be formed. Another thing that is also that hydrochloric acid also reacts with or acts as a strong oxidizing agent. It reacts with strong oxidizing agent. Concentrated hydrochloric acid is easily oxidized. It's easily oxidized by strong oxidizing agent to liberate chlorine. When hydrochloric acid reacts with strong oxidizing agent, chlorine will be liberated. The chlorine attached with hydrogen in the hydrochloric acid will be liberated. It will be oxidized into that. So hydrochloric acid is never used for acidifying solution of oxidizing agents. Because of this, hydrochloric acid is not used for acidifying solution of oxidizing agents. Instead, tetraoxosulfuric acid is used in that case because of it's easily oxidized by oxidizing agents. Another thing we need to note about it is its action on heat or its action on heat. Its action when it's being heated. Concentrated hydrochloric acid is heated. When it's being heated, it boils to liberate hydrogen chloride fume. Its action on heat, when it's being heated, it liberates hydrogen chloride fume, making the solution more dilute. When dilute hydrochloric acid is heated, water is lost, making the residual solution more concentrated. We need to look at how can we test hydrogen chloride. How can it be tested? Now we have ways in which it can be tested. We can test it with ammonia and we can test it with silver nitrate. In the lab, we can test it using ammonia and we can also test it using silver nitrate. When we use ammonia, how can we do it? Hydrogen chloride produces dense white fume in the presence of ammonia, and it consists of suspended particles of ammonium chloride. So when hydrogen chloride is added in ammonia, or ammonia is being added in hydrogen chloride, white dense fume will be formed, and that white dense fume is ammonium chloride. So with that, we can use it to test it. Then another one is when addition of silver nitrate, or we call it silver triazonitrate 5, hydrogen chloride forms a white PPT also of silver chloride. So this precipitate is insoluble in water, but soluble in excess ammonia. So when you add silver nitrate to hydrogen chloride, silver chloride will be formed, which is white PPT will be formed. However, we need to understand that lead-2 triazonitrate 5 can be used in place of silver triazonitrate 5 in this type of test. Lead-2 triazonitrate 5 can also be used in place of silver in this particular test. So this is what we do in the lab when we want to test for hydrogen chloride gas. All right, uses. What can we use it for? Hydrogen chloride gas is used in the manufacture of chloroethene. Hydrochloric acid is used in the manufacture of textile and dyes. Hydrochloric acid is used in the manufacture of what? Glue from tender of animals, and then hydrolysis of starch. We use hydrochloric acid in pickling, that is removal of oxide from metals before electroplating. We use hydrochloric acid in the laboratory, and it's being used for testing, just like we did testing. That means analysis, salt analysis. We use it in analysis. We use it in preparation of other compounds also. So these are the things we use it for. And because of that, we'll look at also chlorides. Chlorides, we want to look at chlorides, the compounds of chlorine. That is what we mean by chlorides. Chlorides. Chloride are normal salts formed when the hydrogen ions in hydrochloric acid are replaced by metallic ions. All chloride except copper 1 chloride, mercury 1 chloride, and silver chlorides are soluble in water. All chloride are soluble in water except these three, except copper 1 chloride, mercury 1 chloride, and silver chloride. Others are soluble in water. Now, lead chloride is insoluble in cold water, but dissolve gradually when warm. Lead 2 chloride is insoluble in cold water, but dissolves gradually when warm. Preparation of chloride. How can we prepare chlorides in the laboratory? Laboratory preparation of chlorides. Now, generally, chloride can be prepared in the laboratory by various methods. But the specific method in which is being used for the preparation of a given chloride depends on the activities of the metal and the nature of the given chloride. So it depends on the reactivity of the particular metal that is being attached to the chlorine and the nature of the given chloride. Number one way in which chloride can be prepared is this: action of hydrochloric acid or hydrogen chloride gas on metals. Of course, when a metal that is more reactive than chlorine, than hydrogen in the electrochemical series reacts with hydrogen chloride gas, it will displace hydrogen from its metal, from that particular, it will display hydrogen from that gas, and it will take its place. So the chloride of a magnesium and zinc are prepared by the action of dilute hydrochloric acid on the corresponding metal. Just like the equation you can see now on your screen, magnesium plus hydrogen chloride, hydrochloric acid will form magnesium chloride. Now here it's supposed to be 2 MgCl2, so 2 is supposed to be here, where you can see the cursor. Then hydrogen gas will also be liberated. The way 2 is on this one, 2 also supposed to be here. So zinc can also display hydrogen here. The same way, aluminum chloride and iron 2 chloride are prepared by passing dry hydrogen chloride over a heated metal. As the equation for the reaction, you can see it below. This is iron react with this to give iron 2 chloride, and the aluminum chloride, aluminum 3 chloride. That is it. Another way in which it can be prepared is action of acid on the oxide, hydroxide, or the triazocarbonate 4 of metals. So action of the oxide, hydroxide, and triazocarbonate 4 oxide, triazocarbonate 4 of metals. The chloride of potassium, sodium, and calcium are prepared by neutralizing their hydroxide with dilute hydrochloric acid, or by adding the acid to their oxide or triazocarbonate 4. As the equation below depicts it, the first one, hydrogen chloride, sodium, and sodium hydroxide, it will give you this. It's supposed to be 1, so this one is not needed. This one also, together with potassium carbonate, hydrochloric acid with calcium hydroxide, it gives you the product as we can have it here. The next thing we need to understand that copper is too active. It's too reactive to It's too active to react with dilute hydrochloric acid. So instead of that, copper 2 chloride is prepared by the action of acid on copper 2 oxide or triazo, supposed to be triazo here, not CO, triazo carbonate 4. This is triazo carbonate 4, not triazo cocates, not cocates, is also triazo carbonate 4. And the equation for the reaction is being represented below. Reaction of hydrochloric acid with carbon and copper oxide, and it will give you this. Now, the next thing we need to understand is this. It can be prepared through double decomposition. Double decomposition. Chloride of metallic lead and silver are prepared by double decomposition. We can prepare it through double decomposition. The double decomposition of lead nitrate and the silver nitrate. And when such is being done, we will get lead chloride and silver chloride. Still know that we are talking about chlorides. Several chlorides, how they can be formed. Copper chloride, we have gotten copper 2 chlorides here. We have gotten lead nitrate, we have gotten silver nitrate, we have gotten potassium nitrate chloride, we have gotten calcium chloride, we have gotten sodium chloride. These are different kinds of chlorides. We have gotten magnesium chloride, zinc chloride, aluminum chloride, iron chloride. So these are the several ways in which chloride can be prepared. Okay, we have talked. The next one now, number 4, is direct combination of the metal and chloride. Directly, we can combine the two particular a particular compound we want to prepare. We just get a direct, the 2 elements and chlorine, the element and chlorine, join it together, and such particular compound will be formed. As you can see, iron 3 chloride, we can bring iron and the chlorine, combine it, and it will give you iron 3 chloride. Mercury and chlorine, we can also do that, and we have chlorine 2, mercury 2 chloride. They can be prepared by direct combination. All right, properties of chlorides. Properties of chlorides, we mean the action of chlorides, action of heat. Chloride does not decompose by heat. Chlorides generally are not decomposed by heat. Chlorides are not decomposed by heat. Just note that one. Number 2 is that with tetraoxosulfate 6 acid, action of chlorides on tetraoxosulfate 6 acid. All chloride reacts with hot concentrated tetraoxosulfate 6 acid to produce what? Hydrogen chloride gas. That is it. As you can see in the equation here, if a strong oxidizing agent is present, chlorine is produced. As you can see here, this is a chlorine ion and a H2SO4, and we can see the equation. And the next one is when manganese 4 oxide is being used, and the product is there. So that's number 2. How can we test chloride? Testing of chloride. How can you test it in the lab? Number 1, we can test it. Number 1, acidifying the test solution with dilute triazonitrate 5 acid. When a solution is being acidified using triazonitrate 5, or you call it nitric acid, then add a few drops of silver nitrates, nitrate 5, triazonitrate 5, a white PPT or silver chloride, which dissolve readily in aqueous ammonia, indicates the presence of a chlorine. It shows the presence of chloride, which here in this case is silver chloride. It shows the presence of silver chloride when a few drops of silver nitrates is being added to a solution, and white PPT is being formed, white PPT or silver nitrate. And such PPT dissolves readily in aqueous solution. It shows that chloride is present there. Of course, we use this in the lab to test for chlorine ion, if it is present. Okay, another one is that we can do that by lead 2 triazonitrate 5 can be used also. And in that case, YPPT of lead 2 chloride, which dissolves when heated, but reappear when cooled, indicate the presence of a chloride also. So we can also use this, of course, though we don't use this one often, rather the other one is what we use often in the lab, but it depends. This one can also be used. Lead 2 triazonitrate 5 can be used, and the YPPT, which dissolves when heated and reappears when cooled, indicate the presence of chloride. And this is it. Lead 2 chloride is that YPPT. Okay, so far we have discussed compounds of halogen, and we have discussed the halogens, the examples of halogens or the halides. We have discussed hydrogen chloride. We have discussed the hydrochloric acid. We have discussed how to test them and all of that. Now, for further discussion and inquiry, you can get to me through my phone line and or WhatsApp line, +234 7322 +234 806557 7329 +234 806557 7329, or send me an email through my email address at christo116@gmail.com. Thank you and being blessed and for being part of this particular video. Thank you.